Hello, today we'll be doing lesson 4.1, Area and Definite Integrals. What is integration? Integration is the process used to find the net area that is under a curve with respect to the x-axis. An integral is shown right here. It has the upper bound, which is the b, and the lower bound, which is the a, and then a function, which is called the integrand. The d of x shows that this function is differentiable. This example right here shows that, or means that, you have to calculate the net area bounded by the graph of f of x and the x-axis between x equals 1 and x equals 4. In this problem, the bounds are 4 and 0, and the function is x. So the graph over here goes to 4 on the x-axis, and here's the function, and because it's with respect to the x-axis, you're drawing the line down here, and this shape is a triangle, so now you have to find the area of this triangle. So the base of this is 4, and the height of it is 4, so it'll just be 4. So it'll just be 4 times 4, which will give you your net area of 16. For this problem, the bounds are 3 and -3, and the function is square root 9 minus x squared. So on the graph, the function makes a semicircle on the bounds of -3 to 3. And to find the area of a semicircle, you use 1/2 pi r squared. And so here, the radius will be half of the diameter, which is 3. So take 1/2 pi 3 squared over here. And this becomes 1/2 pi 9, or so this will just become equal to 9/2 pi, and that's your answer for your net area. For this problem, the bounds are 2 and -2, and the function is 2 of x. In this problem, there is one triangle that is above the x-axis and one below. So for the one above, it will be positive, but for the one below, it will be negative. So you start by make this triangle 1 and this one triangle 2. And for number 1, the base and the height, or the base is 2, and that'll be times the height of 4, which gives you 8. And for number 2, you have the same base, which is 2, and the height, but the height is negative, so it'll be -4, and that'll give you -8. And so now you add these together, and you get 0 as your net area. There are a couple more properties that go along with definite integrals, such as if the bounds are the same, it will automatically equal 0. If the top bound is less than the bottom bound, then the integral is flipped to become negative, and you can swap the lower and upper bounds. If there's a c value, you'll turn it into the c as the upper bound and the a lower bound, f of x. Add that to the c, now becomes the lower bound, and the b the upper bound, f of x. If you have a coefficient in front of the function, you can automatically put that in front of the integral to the left of it. And if you have a function such as f of x plus g of x, you can turn that into the integral of f of x plus the integral of g of x. Now feel free to pause the video and finish these problems as your exit ticket on your own. Thank you for watching.